Hey everyone, this is Genesis Mackenzie. Today I'm going to discuss division of polynomials. It's going to involve monomials, binomials, trinomials, and other types of long um, powers or degrees of polynomials. And specifically, we're going to discuss long division and synthetic division. Now, whenever we're whenever we're dividing a polynomial by monomial, for example, this right here, 8, 81x, x8, you'll see. Y to the first power divided by 9, x to the 8th power, y. Whenever a polynomial is divided by a monomial, we're going to place the monomial under each term. And here there are 3 terms here. And once we place them under these 3 terms, we're going to simplify. Okay, so what we have together, we can break apart. So let's break them apart. Let's break these. You know what? I'll put it under here. 81, this is the first term, divided by 9, 8 power, y to the first power, minus 27x to the 7th power, y to the 4th power. Okay, same thing, and again. Okay, now that we place our monomial under each term, we are going to simplify it. Okay, 9 divided by 81, 9. 81 divided by 9 is 9. Okay, 8 minus 8, both are going to cancel out. Okay, there. So we have 9 y, that's our answer, minus 9 divided by 27 is going to be 3. It's going to be x. This one is going to be y cubed. So we have 3y cubed and x. 18 divided by 9 is 2. Okay, 8 minus 5 is going to be x to the 3rd power. And this is going to cancel out. So the simplified form of this polynomial divided by this monomial is 9y minus 3y cubed over x plus 2x cubed. Okay, that's if we're dividing a polynomial from a monomial. But if a polynomial is divided by a binomial, a trinomial, and so on, right, or a larger polynomial, we use long division. And you guys already know what a binomial looks like. This is a binomial, right? This also is a binomial. And we know that binomial. And this here is a trinomial because it has 3 terms in it. That's a trinomial. Okay, so if the polynomial division is divided by a trinomial, binomial, or a larger polynomial, we're going to use long division. For example, here's what I mean by long division. 23 divided by 5,981, or 3 divided by 2, right? We can use long division for that too. So let's do this one first. Okay. What goes into I put the answer. What goes into 23? That will give us 59. Well, we can try 3, but it will be too high. So 2 times 23 is going to give us 46. That's going to give us 13. Bring down, you carry down the 8, right? Okay, what times 23 equals to 138? It's going to be 6. 6 times 23 is going to be 138. It's going to be 0. And then we subtract it. It's going to be 0. Carry down our 1. Right? What times 23 equals to 1? 0. Right? 0 goes here. 0 times 23 is 0. Goes here. Our remainder is 1. What times 23 equals to 1? Nothing. So we can leave this here as our remainder. That will be our remainder here. And we express our answer 5981 divided by 23. We can express it as 260. I have no space here, so let me move it. Okay. 260 1 over 23. In this case, you can also express it this way: 260 plus 1 over 23. See that? Now, it's important that you understand the terminology of the long division, so that when I'm speaking later and using the terms of each part of the long division, you will understand what I'm talking about. So this part here is called, the answer is called the quotient. This here is called our divisor. And this here is called the dividend. And of course, this thing here is called the remainder. And look how I expressed it. I expressed it in this way. Right? We had I'll put this over here. Here we had our quotient, our dividend, and we had our divisor. And I'm going to use this one at the bottom, okay? It equal to 260 plus 1 over 23. This was my quotient. This is my remainder, 1. And here is, again, my divisor. Same thing with this one. You have 3 divided by 2. It's going to be 2. Well, it's going to be 1. 1 times 2 is 2. Okay, 1. Okay, our answer will be, you can express it in this way: 1 plus 1 over 2. Some people express it this way. Okay, like a mixed term. Same thing. You have your your quotient here, your answer here. You have your remainder here, and you have your divisor here. So when you are expressing polynomials, when you're dividing them, division of polynomials, you must express it in this way. You're going to have your dividend. Your dividend is called f of x. Your divisor here is called d of x. Your remainder is r of x. And your quotient here is called q of x. So we have, it should always be expressed when you want to express yourself. F of x, or f at x, when f at x is divided by divisor d of x, it will be q at x plus remainder, which is r at x, over your divisor. And again, this is your quotient. more answer, right? Your answer, remainder, divisor. That's your dividend, right? And this is your divisor. You have to express yourself in this way when you're giving us the answer of polynomial division. Okay? Now let's do an example of polynomial division, applying moving from simple math to something more complex. Like, for example, let's do this problem. How about 3x squared plus 8x minus 3 divided by x plus 3. Let's do it. 3x squared plus 8x minus 3. Put it in this form. Now we're going to ask ourselves the question, what times x equals to 3x squared? Okay, it will be 3x. Right? 3x times x is equal to 3x squared. And we do it again. After we get this, we got to do it again. 3x times 3 will be equal to 9x. Now we're going to divide it, right? And we're going to do what we do. We're going to do the same thing that we do in long division. We're going to subtract it now. Subtract it. So this was positive, right? This is positive, right? Now the signs are going to change from positive to, cross it out, negative. Positive to negative. Now I like to cross them out because what usually happens is that I forget to change the signs. So now that I found that when I put what was there and then change the signs later, I avoid confusion and I avoid mistakes. So 3x squared minus 3x squared is going to be 0. Okay. 8x minus 9x is equal to negative x. Now bring down this term here. It's going to be negative 3. Now we ask the question again. Oopsie. What times x equals to negative x? And our answer will be negative 1, right? Negative 1 times x equals to negative x, doesn't it? Then we do it again. After we get this, we do it again to this one. Negative 1 times 3 is equal to negative 3. And we're going to divide it. So we're going to change signs. This is negative, so it becomes positive. That was negative. I'll cross it out like that. I'll put a positive here. Good. Now that cancels out. That cancels. It's going to be 0. So my remainder is 0. What times x equals to 0? 0, right? I'm done. And remember, I express it in this way. Remember this was my f of x here. This here is my answer, or my quotient 2 of x. This here is my d of x. This is my remainder. My remainder is 0. So I'm going to express the answer in this way. The divisor f at x over d of x is equal to my quotient, which is 3x minus 1, and my remainder over my divisor, plus my remainder of 0 over my divisor. And anything anything that has a 0 in the denominator and the sorry, a 0 in the numerator and a and a anything in a number or a expression in the denominator will be equal to 0. For example, 0 divided by 2 is equal to 0. Okay? So this is 0, it's nothing. So this will be our answer. Okay? You can express it this way or you can express it in this way. Up to you. But that will be our answer here. Let's try another one. Okay? How about 4x cubed plus 13x squared minus 2x minus 15 divided by 4x plus 5. Okay? We have 4x plus 5, 4x cubed plus 13x squared minus 2x minus 15. Okay, oops, that is getting bad. I'll change the blue. Okay, we ask ourselves the question, what times 4x equals to 4x cubed? And our answer is x squared. X squared times 4x equals to 4x cubed. And we go again. We multiply x squared into all the terms, all the divisors terms. So x squared times 5 is going to be 5x squared. All right, we're done. We're going to subtract terms, and this was positive, but wasn't. Right, that was positive. So we're going to change the sign to negative. That was positive. We're going to change the sign, cross it out, and make it negative. Okay, 0, and crosses out. 13 minus 5 is 8. X squared. Bring down this term here, which is negative 2x. And we ask ourselves the question, what times 4x is equal to 8x squared? And I say the answer is going to be positive 2x. So positive 2x, let's move this out the way. 4x plus 5. Positive 2x times the first term is going to be 8x squared. Positive 2x times the second term, which is 5, is going to be positive 10x. Now we subtract it. This is positive, right? That was positive. Cross it out. It becomes negative. It's positive. Cross it out. It becomes negative. That cancels out. Right? 0. Negative 10 plus negative 2. A negative plus a negative is really negative. It's going to be negative 12x. Okay. Now we're going to bring down this negative 15 here, this term here, negative 15. And we ask ourselves the question again. What times 4x? What times 4x equals to negative 12? Let's say negative 3. Negative 3 times 4x is equal to negative 12x. So we put it in the first term. We do it again to the second term. Negative 3 times 5 is going to be negative 15. Now we're going to subtract. This is negative. Cross it out. It's going to become positive. That's negative. Cross the negative sign out. Change the sign. It's going to become positive. That crosses cancels out. That cancels out. Our remainder is going to be 0. So we expressed our term. We have here f of x on top. This whole long thing here. divided by d of x on the bottom is equal to our quotient, which is x squared plus 2x minus 3, and there's a remainder is 0. So we're good. Okay, let's do another one. But first I want to say that, long division here can be helpful in finding zeros of polynomial functions. Zeros are our x-intercepts or our roots. For example, we previously divided this function here. We had this. It was 3x squared plus 8x minus 3 divided by x plus 3. Remember that one? And our answer, we had a 0 remainder. 3x minus 1. Our remainder was 0. Okay. So the factors, this was our quotient. This was our answer, right? Our quotient. So the factors 3x minus 1 and x plus 3 equal to 3x squared plus 8x minus 3. Right? And if we if we try to find the zeros for this one, we take this one out. We set this x plus 3 equal to 0. X will be equal to negative 3. So that will be a 0. Right? That will be a x-intercept. We do the same thing with this one. 3x minus 1 equals 0. Right? Solve for x. The 1 goes on both sides. Then we have 3x equals to 1 divided by 3. Right? X will be equal to 1/3. So we have another 0. Zeros will be x equals to 1 over 3 and x is equal to negative 3. Right? So this is how long division can be helpful in determining the zeros of polynomial functions. But guess what? Sometimes there is no remainder. We can only do this when the remainder is 0. Well, let's say sometimes, sometimes the remainder is not 0. For example, let's say we have 6x minus 8x minus 3 divided by 6x minus 2. Okay, put it in this form. 6x minus 2 and 6x, squared, forgot to square, 6x squared minus 8x minus 3. We ask ourselves the question, what times 6x equals to 6x squared? Well, it's simple. It's going to be x. X times 6x equals to 6x squared. Right? So we put it in the first term, and then we do it again to the second term. X times negative 2 is equal to negative 2x. Now we're going to subtract the whole thing. This was a positive in front of it. Now this becomes a negative. This is negative, so it becomes a positive. Okay, and these two cancel out. That's going to be 0. 6 plus x squared minus 6x squared is 0. Negative 8x plus 2x is going to be negative 6x. Carry down this negative 3 here. And we ask ourselves the question again. What times 6x equals to negative 6x? Our answer is going to be simply negative 1. Negative 1 times 6x equals to negative 6x, doesn't it? Do it again. Negative 1 times negative 2 is going to equal to positive 2. And we're going to subtract, so the signs will change. This is negative, now it's going to become positive. This is positive, this will become negative. 6x squared plus 6x squared. Negative 6x plus 6x is 0. Negative 3 plus negative 2. Negative plus a negative is really negative, so it's going to be negative 5. That's going to be our remainder. And then we express this term this way. Remember, we should express it f at x over d of x equals the quotient at x plus remainder at x over divisor at x. So look at it. We have our quotient here, which is we have our f at x here. We have our dividend here, dividend and divisor here. Our quotient will be x minus 1. Our remainder will be negative 5 over 6x minus 2. So plus negative 5 over 6x minus 2. Okay, we can also just change this to negative 5, okay, over 6x plus 2. So this, and this. Okay, let's do another one. This time, I want to have something harder. How about when we have long division, right? And we have these things called we have missing terms. Missing terms. What you got to do when you have missing terms is to make sure that you arrange the order of the terms in descending powers. For example, let's say you have x to the 5th power, right, plus x to the 2nd power plus 1. Okay, first you have to make sure that you arrange the terms in order of descending powers. Let's say you have another one like this one, x to the 4th power plus x to the 6th power plus x, right, plus 1. Well, first of all, so this one is already arranged in order of descending powers, but look, we're missing terms, aren't we? So what we got to do when we're missing terms is put in placeholders. So it should look like this: x to the 5th power plus x to the, the placeholder will be 0x to the 4th power plus 0x to the 3rd power plus x squared. What else is missing? X to the 1st power. So it can be 0 x to the 1st power plus 1. Let's look at this one. Look, first of all, it's not arranged in order of descending powers, so we got to put it that way. First, we have x to the 6th power plus x to the 4th power plus x to the 1st power, right? Our invisible 1st power plus 1. And guess what? We have missing terms too here. We're missing 5th power, 3rd power, 2nd power. So guess what? We have to put placeholders here. So this has to become x to the 6th power plus our placeholder 0x to the 5th power plus x to the, our 4th powers are here. 0x to the cube plus 0 x to the squared, x to the 1 is there, x to the 1st power plus 1. So that's what you got to do before you do the long division. You have to make sure that you have no missing terms, and if you do, you put in placeholders. And you got to make sure that it's in you arrange the expression in order of descending powers like this. Let's do a problem with missing terms. Let's say we have this. X to the 3rd power plus 4x squared plus 5 divided by x to the 2nd power. Now, are we missing terms? Yes, we're missing terms. We're missing x to the first power. And it's already arranged in order of descending powers. At 3, 2, we're just missing 1, and then 0. Another thing I want to say about this one here, right? This constant here. What's going on here is really this, x to the third power plus 4x squared, right? Plus, let's put our placeholder in, x to the first power, right? Plus 5. What's happening here is this, 5x to the 0 power. Remember, what's the answer to this? If 5 is equal to the 0 power, what will the answer be? It will be 1. If 2 is equal to the 0 power, the answer will be 1. If x is equal to the 0 power, the answer will be 1. So that's what's going on here. It's 5x to the 0 power. And this x to the 0 power is 1. 5 times 1 is 5. That's why it's just given that you know that this is a constant, 5. And you don't have to always put x to the 0 power. It's just given that you know it already. Okay? So, first we take the divisor here. Make sure that we don't have missing terms. We do have missing term. It was this one here, x to the first power. We put a placeholder of 0, 0, x to the first power in here and put it in descending order, right? And then we look at the numerator. We find out to see if we have any missing terms, and we don't. We have x to the first power and then plus constant. So we're good. Now we can apply our long division. X plus 2, x to the third power. Make sure it must be in descending order. If you divide this polynomial and it's in the wrong order, you're going to be completely wrong. The actual question: what times x equals x cubed? X squared. X squared times x equals x cubed. X squared times, do it again, x squared times 2 is equal to 2x squared. Okay, then you subtract it. This is positive, it's going to be negative. This is the positive, it's going to be negative. That cancels out. 4 minus 2 is going to be 2x squared. Bring this down, plus 0x to the first power. The extra question again, what times x equals to 2x squared? It's going to be positive 2x. 2x times x is going to be 2x squared. 2x times 2 is going to be positive 4x. You're going to subtract. This is positive, it's going to be negative. This is positive, it's going to be negative. That cancels out. Negative 4. Bring down this 5 here. Positive 5. We have to set the question again. What times x equals to negative 4x? It's going to be negative 4. Negative 4 times x is equal to negative 4x. Negative 4 times 2 is equal to negative 8. This is negative, it's going to become positive. This is negative, it's going to become positive. That cancels out. 8 plus 5 is 13. What times x equals to 13? Nothing. So we're done. And we're going to write it in this way. F at x, which is our divisor. Our divisor is right here. Divided by our dividend is here. Our dividend is here. Our dividend divided, which is f of x, divided by our divisor, which is d of x, is equal to our quotient, q of x, which is equal to x squared plus 2x minus 4 plus remainder, which is 13. 13 over d of x. 13 over x plus 2. Okay? And there you go. That's how you do it. Okay, let's try another one. Let's try x cubed minus 1 divided by x minus 1. And we ask ourselves, is it in is the polynomial arranged in order of descending powers? And yes, it is. 3 and there's a constant here. The same with this one. Is it missing terms? Yes, it's missing terms. So we're going to put placeholders in this one. It should be x cubed plus this placeholder of x squared plus another placeholder of 0x to the first power minus 1. This one is good. So let's divide it now. x minus 1 divided by x cubed plus 0x squared plus 0x to the first power minus 1. What times x equals to x cubed? X squared. So we multiply this one, then we're going to multiply this one. X squared times it's going to be x cubed. X squared times x is going to be x cubed. X squared times negative x. No, x squared times negative 1 is negative x squared. Now we're going to subtract. This is positive. We're going to cancel out, and we're going to change the signs here. It's negative, change it to positive. That cancels out. It's going to be x squared. Bring this down. 0x to the first power. Then we ask ourselves the question again. What times x is equal to x squared? It's positive x. Positive x times x equals to x squared. Positive x times negative 1 equals to negative x. Then we're going to subtract. This is positive. It's going to change. The sign is going to change negative. This is negative. It's going to change to positive. That cancels out. X. Bring this negative 1 down. We ask ourselves the question again. What times x equals to x? Positive 1. Positive 1 times x equals to x. Positive 1 times negative x. Positive 1 times negative 1 is equal to negative 1. Right? This is positive. The sign changes to negative. This is negative. The sign changes to positive. Our remainder is going to be 0. So f at x divided by d at x is equal to x squared plus x plus 1. Okay? So that's how you divide, use long division when there are missing terms. Now there's something else that we're going to do here. We're going to learn how to do synthetic division. Now, long division can always be applied anytime, right? If you have a dividend and a divisor. But synthetic division is limited. It can only be applied when your divisor has the form x minus a real number, or x plus a real number. For example, x minus 3, or x plus 3, or x minus 9, or x plus 8. Okay. And synthetic division looks like this. You have the L shaped thing, and you have something like 3, 12, 13. It looks like that. This L shaped thing gives us a clue here. And what you're going to do is bring down the 3. After you bring in the 3, you multiply the 3 times this 3 here, right? 3 times 3 is 9, right? This is going to be remainder. And 12 plus, you add 12 plus 9, it's going to be 21. Then you multiply 21 times 3. It's going to be 21 times 3 is going to be 63. And 63 plus 13 is going to be 76. So you'll have this quotient here, and you have this remainder here. I'll explain to you with another example. I'll just explain how to do it. Okay, let's say we have, remember, we can only apply synthetic division when we have something like this, right? X plus some real number, x minus some real number. So let's say we have this here. X to the 5th power plus x to the 3rd power plus 5x squared plus 5 divided by x squared plus 1. So let's apply synthetic division to this. Oh, we can't, because look, x squared plus 1. We have to use long division. Just playing with you guys. Okay, let's say we have this term here. This polynomial division here. 3x squared plus 8x minus 3 divided by x plus 3. So what we're going to do here is take the dividend here and put it up here. 3x squared. You gotta make sure that there are no missing terms, and in this case there are not any missing terms, and it have to be in order of descending powers. So 2, 1, 0. Pull down your L-shaped thingy, okay? And then take the numbers out. That's 3. It's going to be here 3. This here is 8. It's going to be 8. This is -3. It's going to be -3. This last number will be your remainder section. Now, you're going to divide it from this factor here. In order to divide it, you take this out, set x plus 3 equal to 0, solve for x, right? X will be equal to -3. So you put -3 here. That's going to be your divisor. And remember we just did, pull this down, this 3 down, it becomes 3. 3 times -3 is -9. Then we're going to add this together. -9 plus 8 is -1. And -1 times 3, -1 times -3 is a +3. And look, -3 plus -3 is 0. This answer here is our remainder. We have a remainder of 0. And this here is our quotient, our answer. Right? And how do we write it? Well, we look at what we look at our dividend and what we divided from, and we notice that it was a square. So we divide it down. So here's how we write it. We're going to take this, and it's going to be 3. It wouldn't be squared. It's going to be 3x 2, but it'll be 3x 1. This was 2, now it's going to be 1. So 3x 1 minus x, because actually literally it's this, minus 1x, right? Can't have that. The 1 is invisible, okay? So if you're thinking 1x, you're correct. So, but we just don't write the 1. And our remainder is, well, in this case we can write the 1, because it's -1, because there's no other number, right? So we're good. And there's an invisible 0 there, right? Plus 0 over, our dividend was -3, right? We put it back into this form. So what I mean is we have this form here, x is equal to 3, -3. You're going to put it back over there. Okay, x plus 3, okay, is equal to 0. So you'll have x plus 3 here. Anyway, if 0 wasn't in the numerator and anything is in the denominator, the answer would be here 0. So our remainder, everything here is 0. This will be our answer. This will be our Q of x. Right? Remember, you write it like this: f of x divided by d of x is equal to 3x minus 1. Okay? Let's try another one. Let us try 2x squared. We may or may not have missing terms. I'm going to erase that. It's annoying. I have more space. 2x squared plus 5x minus 3. That's a square. Sorry. Divided by x minus 3. Let's do it again. Take this, right? And we're going to draw our L-shaped thingy. 2. It's, remember that our powers are arranged in descending order. 2, right? 1, 0. Good. So we have 2 here. And we have a 5 here. And our last number will be over here, -3. And we're going to take this x minus 3, set it equal to 0, solve for x. X will be equal to 3, put 3 here, right? Bring down your 2. Now, 2 times 3 is equal to 6. 5 plus 6 is equal to 11. 11 times 3 is equal to 33, right? 33 minus 3 is going to be 30. Hey, that's going to be our remainder. We look at our highest power, it's going to be 2. So this is going to be 2x1 plus 11. Remainder is 30 plus 30 over divisor. We look at this, we change it back to this form, x minus 3 form. That's going to be our answer. F at x over d at x is equal to this. Okay. Let's try another one. It's going to be a little bit more difficult. Okay, try pausing the video and solving this one. X to the 6th power minus 27 divided by x minus 3. Well, first thing I notice is that it's in order. It's arranged. Well, it was arranged in order of descending powers. In this case, I just switched it around to show you what's not in the right order. This is not in the right order, right? So we got to make sure it's arranged in order of descending powers, like this. And the second thing, we look for missing terms. Are there missing terms? Yes, there are missing terms. There are no missing terms in the denominator. This is fine. X is 1, x is 0. Okay. So we have to go 6. X to the 6, we're missing, I don't think we have space for this, so I need to go around the bottom. X to the 6th power plus a placeholder x to the 0x to the 5th power plus 0x to the 4th power plus 0x to the 3rd power plus 0x to the 2nd power plus 0x to the 1st power minus 27. It's very long. So let's take this long thing and apply synthetic division to it. It's going to be even shorter. Look at this. Put our L-shaped thingy, right? First one was 1, then 5, 4, 3, 2, 1, -7. Happy birthday. Okay. I'm not playing around. And then we take this x equals -3. Let's take x equals to 3, set it equal to 0. Solve for x. X is equal to 3. Put the 3 here. Okay. Now let's apply synthetic division. Grab this 1, put it down here. Right. So it's gonna be 1. 1 times 3 is 3. Right. 3 plus 0 is 3. 3 times 3 is going to be 9. 9 plus 0 is 9. 9 times 3 is 27. 27 plus 0 is 27. Now 27 times 3 is going to be 81. 81 plus 0 is 81. And 81 times 3 is going to be 243. 243 plus 0 is 243. 243 times 3 is 729. 729 minus 27 is 702. So this is our remainder here, or x. This is our answer here, q at x. And how do we write it? Well, first we look at our highest power here, which is 6. It was 6, so, and we divided it by a binomial. So it's going to be from 6 to 5. So it's going to be, our answer will be f at x divided by d at x is going to equal to 1 will be 5. X to the 5th power plus 3x to the 4th power plus 9x to the 3rd plus 27x to the squared plus 81 x to the first power, and I have space here, plus 243 plus remainder 207 divided by our divisor, x minus 3. That's a long answer. Look at that. Look at that baby. But we did it. Right? You did it. If you solve this, pat yourself in the back and grab yourself a good energy drink or something and take a break. So we have done synthetic division of one of the longest ones. So I'm proud of you that you've done it on your own. And if you didn't, go back and try it again. Okay. Now there's something that you need to know. It's called the remainder theorem. And basically how the remainder theorem works is, let's say for example you have a real number, right? And it's being divided by a dividend. For example, x cubed plus x squared minus 2x, and it's divided by x minus 3, right? If you want to know what the remainder is, we call this the remainder theorem. Remainder theorem. Because when you do the remainder theorem, and this is a shortcut way to get the remainder, okay, when you basically what I'm trying to say, when you do the remainder theorem, it's a shortcut way of getting the remainder. Should have been a statement. Okay, so what will happen is you take this x minus 3, again, set it equal to 0, and x will be equal to 3. Okay, now this top number, which is your f of x, you would change f of x to this here. You change x into 3. So f at 3, you put 3 in. Change all the x's to 3's. Okay, and solve for this function. 3 cubed is going to be 27, plus 3 cubed is 9, minus 2 times 6 is 6. And so our answer is going to be 30. This answer here that we got, this 30, is going to be our remainder. How do we know? How do we know it's true? Well, let's do it. Let's do some, let's prove that this is 30. Okay? I'm going to prove it to you. That this remainder theorem works. Okay, so we have our problem here, x cubed plus x squared minus 2x, right? It's in descending order, but guess what? We're missing something. We're missing this term. We're missing this right here, a constant, where x equals to 0. Right? Remember that. So we have to put it here. We have 1. Draw our little L box thing. 1. We have 1 here. We have negative 2 here. And look, we have that missing term here, which is 0. Right? Yeah. So, and we're going to set this equal to 0. X will be equal to 3. Okay? Bring down this 1. 1 times 3 is 3. 3 plus 1 is 4. 4 times 3 is 12. 12 minus 2 is 10. 10 times 3 is 30. And look, 30 plus 0 is 0. Look at this. We have a remainder of 30, right? Our answer, just for our sake, the highest power is 3, so our answer, our quotient, will be x squared plus 4x plus 10 plus the remainder of 30 over x minus 3. That will be our answer. Anyway, the remainder theorem works, right? It's 30. It's 30. Let's try another one. How about this one for the remainder theorem? 2x squared plus 5x minus 3 over x minus 3, x plus 3. What's the remainder for this one? Let's use, if they give you the actually for the remainder of it, all we got to do is apply the remainder theorem. Okay, well, we make sure everything is in descending order, yes, and we're not missing terms. 2, 1, 0. Great. So we just down x plus 3, set it equal to 0. X will be equal to negative 3. Right? 2, 5, negative 3. Bring out a 2 here. 2 times negative 3 is going to be negative 6. Negative 6 plus 5 is negative 1. Negative 1 times negative 3 is going to be positive 3. Negative 3 plus 3 is going to be 0. Our remainder, our r of x, is 0. And we look at the high, if we want to write it, our highest power is here. We look at this, it's going to be, our highest power is 2. So this is going to be 2x1 minus constant 1. F at x. Sorry, you didn't see that. It's going to be, our highest power is 2. So our answer will be f at x is equal to b at x equal to quotient 2 x to 1 minus 1. Right? Our remainder is 0. That's our answer to this one. So the remainder is 0. It works. Okay. Now there's another theorem called the factor theorem, and basically, what you're trying to determine is if a divisor d of x is a factor of a dividend. For example, that's a divisor, that's a dividend. And you ask the question, is 2 a divisor of 4? And look, it is. 2 times 2 is equal to 4. We know that because our remainder is 0. And that's the thing. So when we're doing our remainder theorem thing, right, and we get a 0 or a remainder of 0, then, and you ask the question, is the divisor a factor of 4? And the answer is yes, because the remainder is 0. So it works out the same with algebra. Is x plus 3 a factor? A factor of f at x equals to 2x squared plus 5x minus 3? Is it? Yeah, that's fine. We just apply the what we just did. We have 2 here, we have 5 here, we have negative 3 here. Okay, that will be negative 3. Bring down our 2. 2 times 3 is negative 6. It's negative 1. That's positive 3. And look, our remainder is 0. Alright, so because our remainder is 0, x plus 3 is indeed a factor of this function. And that's how you use the remainder theorem. And that's basically it with monomials, division of polynomials by monomials, long division, and synthetic division. So I hope this is understandable. Take care and see you next time.